What's up guys, my name is Mike, I am a software engineer, algorithmic Forex trader, and recently I live in Thailand as an expat. Currently it's raining, but yeah, that's what you get if you want to live in the tropical country and avoid winter. Anyway, for those who are new to this channel, if you are interested in algo trading, feel free to subscribe to this channel and join our Discord group to exchange ideas regarding the trading the market. And now let's move to the main topic of this video, which is me sharing my journey on building proper software for latency arbitrage algo trading. So let's see when we stopped last time. In the previous video, I managed to build small piece of software using the test-driven development approach, which requires more time, but in the end, the code base is cleaner and more stable, so it was worth it. I focused mainly on creating the module for accessing the engine from front end. The technology used for the communication was gRPC with all the models and services for the engine access defined in proto files. This approach ended up as the success, as all the integration tests designed to test all the functions that our front end will be using passed, leaving nice smooth list of green color blocks. So the next thing was to start implementing the core of trading engine where all the algo trading activity happens. And to sum up, we have working access to our engine, we have tests for this, so now it's time to develop the broker connections, exchange connections, market data streams, send order and receive confirmation of sending the order and stuff like this. So let's try to replicate this approach while developing the core of the cores of the cores of our trading software, which is the trading engine. And what I mean by that, let's try to first properly design all the entity models that would be used in the hot path of our application. And by hot path, I mean the critical path of the software where low latency is required. You know, I just wanted to design this for the last time with the proper approach, with proper naming conventions, to do not come back to this in the future. You know, in the trading domain, you may have new exchange connection and new securities to trade, but the main logic always stays the same, as you have prices, you have a detailed order book, and you submit your orders based on the order book. So it's the same for every trading domain, whatever it is: Forex, options, stocks, crypto, energy, or even shoes listed on StockX exchange. So it's just all the same. So I was thinking, if I properly focus on designing every single scenario that happens in the trading domain and code it, I will have all the trading events covered, so then there will be no need to ever come back to this part of code. So that was my initial plan. Maybe would you like to know how I designed all my entities? I came up with this design. So let's start with the basic approach to this design. So what is the object that is on the top of the hierarchy? So of course we need the repository of all the connections. So this is a simple class that would hold a list of connection adapters. So basically each connection object would represent the connection to the exchange or broker. So let's see what each connection should have. The connection adapter. Each connection adapter should have the market data engine and the trade data engine. Market data engine will seal within itself all the logic related to streaming the market data, and trade data engine will seal all the logic related to sending the trade request and receiving the confirmation. Usually in the trading systems like fixed protocol, you would have two separate connections. One connection to stream only the market data, and second connection for the managing of the orders. And of course we need something to define if the connection to the exchange or broker is connected, and also ping would be useful to check how far we are from the exchange, to check the latency, you know, of the connection. So let's check what is going to be in the market data engine. So if we go by the green line, we have the market data engine, and this object of course should store the market data instrument DTO, data transfer object, but let's say it's a dynamic object. So we should have a list of our instruments, our securities to trade, and also information if it's connected or no. The same thing with the trade data engine. We need to have a list of active trades, we need to have a list of closed trades, and also information if it's connected or not connected. So basically those objects, the market data engine and trade data engine, are for the managing the connection, the stability of the connection, and managing all the business related activity in their domain, like streaming data. So streaming data will be only in the market data engine. So let's see what we will have in the market data instrument. So if we go further, in market data instrument we should have the order book. So basically market data instrument is just a object that will store the ticker, the information of the security that we can trade. And of course we need something like ID, the name, the matching symbol, and I designed this in that way that the name would be the name that the user that we assign in the software. So let's say we just add security and we say it's gold or Euro USD or Bitcoin. So it's the name that we define. And matching symbol is the ID on the exchange side, of the broker side. So basically this is the name that we will use it in our software, and matching symbol is the symbol that exchange is using for that particular ticker. And of course information, the bull flag, is it subscribed or not subscribed, and also the digits after the comma. So if we want to calculate the pips differences, we will need the digits. So let's see what's inside the order book, because in market data instrument we did not define the ask and bid price. So let's see what's inside the order book. So in the order book we have the order book depth object and the order book entry, which is best bid and best ask. And also we have like spread, tick counter, ticks last minute, and last refreshed. Last refreshed, of course, I do not have to explain. Spread also, the difference between bid and ask. Tick counter is basically how many ticks happened during the active session of this instrument, and how many ticks happened in last minute. So if we go by the orange line, we have this order book depth. So this object is designed to store the entire order book. So we have one list of the sell orders and one list of the buy orders. And also we have the information that if the order book is enabled or disabled, and also the depth size. The depth size, we need this parameter because we want to pre-allocate the entire memory on the application initialization. So in this case, when we start our application, the app will take the depth size of the order book and create list with that many objects of order book entries that we have in the depth size. And then when new information about the order book comes in, it will be pre-allocated, it will be updated in those lists, in those objects. So let's see what's order book entry. So this is the most basic object in the entire flow of streaming market data. So we got the order book entry, which is just simply a price and volume. And yeah, so let's say we have the order book for the sell orders. So we will have just the prices of the sell orders for how much people want to sell, and the volume. The same thing for buy. And when this thing will get updated, the order book, the entire order book also will get updated with the best bid and the best ask. So in that case, we have the ability to store the entire order book or just to store the top of the book. So like we checked before, the trade data engine has the list of active trades, list of closed trades, and the information, is it connected or not. So if we want to do any other activity, we can just take the object from active trade or take the object of closed trade and just put it in some functions related procedures and just use it in our software. So let's move further. What do we have in active trade DTO? So the active trade will represent the trade that we made. So of course it's the ID that we will use in our software, and here we got the order result and trade management information. I split it like this because when you send the order to the exchange or to broker, you need to receive the result from them. If the order was processed fully or partially, or was rejected, not enough money, or price record, whatever. So let's see what we got in the order result DTO. So if we go that way, the order result have the information about the order processing status. And let's see what's that one. Order processing info is just the information if the order was processed or no. Let's see, this is a class and we have order processing status here, and it's the enum, so it defines if the order was filled, pending, cancelled or rejected. So if we come back here, we define, we just send the order, we receive the response, and we know if it's filled, pending, cancelled or rejected. And then if it's cancelled or rejected, we also have a field to put our message in. So maybe, let's say we sent order, we got the rejection from here, and the reason would be not enough money, or we have the order price information. And what do we have in here? Order price information, we have just requested price, filled price, spread and volume. So just info about the prices. Let's move further. We have the order time information, so all the data related to timing will be stored in this object. So let's go here, order time information. So here we have the date time of sending the order, the date time when we received the response, and the duration, how much time it took. So basically it's almost the same thing as the request price, field price and the slippage. So it's the same with the timing. We calculate here the duration of the processing of the order. I hope that makes sense. Anyway, let's move further. This object will define who sent the trade in our application, because it can be us that we click manually open order, or it can be algo. So if we go here, we have the origin ID. So this is the ID of the object that sends the order, and here we have the origin type, and this is just the enum object. So we have manual algo. So here we define if the trade request was sent manually, so by us, or by algo. And in case of algo, we will have the origin ID here. That will be the ID of the algo that sent the trade. Hope that makes sense for you. Okay, moving forward. The next thing is order symbol info DTO. I think I misspelled here. Order like this. Symbol info. So what's that one? Let's follow the line. Order symbol info is just the name of the security, the name of the instrument that we make the trade. So we have the ID of this instrument, we have the name, let's say Euro USD, and of course we have the matching symbol on the exchange, on the broker side. So this name and this ID will be to recognize this symbol inside our application, and matching symbol will be the information to recognize the symbol on the exchange side. So this is very important. And moving forward, we have the last one, order execution information. So this info, if we follow the line, we have the execution info like order direction, order execution method, or order type. So what's behind those names? So let's see, what is order direction? If we follow the line, we can see that this is enum. It just defines if it's a buy trade or sell trade. If we go here, order execution method, we got many different types of executions, like we have standard execution with the MetaTrader 4, or when we trade the fix protocol, or with the exchanges, we can use FOK, which is, let's say, which is first or kill exchange. So we have the FOK approach or FOC. So basically, this information tells the exchange, tells the broker how to execute your order. And the last one is the order type. And if we follow the line, we can see that we have the market order, which is the instant execution, or we have the pending order. So we want to put our order in the order book and wait for our price to execute our order. So order execution info is just the information that tells the exchange and our software how to execute our order. So if we go back here, we have the order result. Let's go back. We had the active trade, so we had the orders, and now let's go with the closed trade. So when we open the trade, we want to close the trade, and what information we need to store. So if we go to close trade, it's pretty much almost the same like in the open trade object. So we have the ID, we got also order result DTO. This is the same one like that one. And we have the order result DTO for closed order. So when we have a trade, basically in the microstructure of the market, the trade consists two orders, the buy order and the sell order. And someone may call it the open trade and the close trade. So again, these are two operations, and we can get filled, we can get rejected, we can get requoted in all of those situations, because we send the order to execute some action on the market and we get the result. So we have again close order for closing the trade. So we also have the price, time, origin, symbol. So in that case, we will have the price of open order and the price of the close order, the requested price and the executed price. And here we have the trade management information. I forgot about this, but we also have the trade management information in the active trade. So let's see what's behind this. So if we go here, we have the trade management information object, and basically this object just defines the stop loss, the virtual stop loss, the take profit, the virtual take profit, and the actual profit, the PNL. So let's say when we open a trade, right, we get the executed price, requested price, and basically the order is open, let's say for a buy position. Then in here we want to put some stop loss and take profit, you know, based of the algo. But here we will not store the parameters in pips, because every single trader, every single algo basically defines this on the go based on their parameters. So for the system, it will just store the prices of close the trade. For example, we have the stop loss and the virtual stop loss. The stop loss will define, let's say in MetaTrader 4, will define the stop loss price that is submitted on the exchange, on the MetaTrader 4 broker. So if you manually on phone, if you just put a stop loss, basically this will be the stop loss that will be executed whenever we are connected to the exchange or not. And the virtual stop loss will be the price that will be not visible on the exchange, on the broker, but will be stored only inside in our software. That's why it's called virtual. And the same take profit, and also the profit is just the profit in pips. So here we store only the prices. And yeah, that's the design. If we just go here, you can see that we designed entire logic, I would say, for the trading activity, because we can now stream data, we can get full order book or just top of the book. Basically, we just keep on receiving market data. We have modules for that. And also we have modules for submitting the trades, for displaying open trades, closed trades, and stuff like this. So this is the design, and I don't know, guys, let me know in the comments if I missed something. Maybe you would like to add some features or change anything, or I made some mistakes in here. If you spotted anything, let me know in the comments so I can correct this. In the next video we will do some actual coding. Thanks for watching, guys, till this very end of this video. If you like this content, please hit the like button below and subscribe to this channel, as the growing number of subscribers helps keep me motivating to produce more content like this for you guys. So if you also like exchanging nice ideas about the algo trading, feel free to join our Discord group, Discord community. The link should be somewhere down below in comments or description. But anyway, thanks for watching and see you in the next video.